So how many slices were taken?
One.
So what fraction of my pizza was taken? If one slice was gone, how many were there to start? 6. So if one of those 6 slices was taken, that fraction is 1/6 of the pizza. If there are 2 people who are going to share this first pizza equally, how many slices does each person get? They're going to get 3 each. Well, how do you know? Well, there was 6 equal slices in the pizza divided by 2 people. So each person's you saw it already, 6 divided by 2 is 3. So what fraction of the pizza does each person get? They get 3 slices of the 6 that started. Or, if I take a pizza and I divide it between 2 people, what fraction does each person get? Ethan, if you and I are going to sit down and I take, there's 6 pieces and I take 3, you take 3. How much of the pizza would you have? You'd have 3 slices or a half. So 3 of 6 slices is, we say this is equivalent or equal to a half. And how we simplified that, we'll talk about it in a sec. So how many slices would each person take if there was 6 people? Well, if you had 6 people, each person took some of the 6 slices. You get 1 of those 6. Okay, fractions have 2 parts. What do we call the top part of a fraction? What's the language there that we use to represent the top part of a fraction? Yes. It's the numerator. So the numerator is that top part, or in the examples we had previously, it's the number of equal parts taken. And the bottom of the fraction is called the denominator. Love it. That guy there. It's how many there are in all of something, the whole of the thing. There are different kinds of fractions. There are what we call proper fractions. There are what we call improper fractions. And there are what we call mixed fractions. Can anyone tell me what a proper fraction is? You gave me an example. You said 1/6 is a proper fraction. What makes that fraction? It is. What makes the fraction proper? Good guesses. Okay, before I give you a definition, maybe you can tell me what an improper fraction is. Garrett.
5/4.
Something like 5/4. That is, in fact, improper. What is the difference between these 2 kinds of fractions? Garrett.
The proper fractions, the numerator is always the denominator.
And in an improper fraction?
The denominator is more than the denominator.
Perfect. Let's write that in there. So in a proper fraction, the numerator is less than denominator. And in an improper fraction, the denominator is less than the numerator. Cool. So we've got a proper, we've got our improper, and now we've got mixed. What is a mixed fraction? Who remembers? Sometimes this is also called a mixed number. I don't know if that changes anything, Garrett?
Is it like 5/4 equals, 6, with the 2 on the side. I can't remember what the exact,
So like that?
yeah.
You betcha. Well done. The memory is there. That's great. So what makes, if you have to use words now, what's an improper fraction? Sorry, what's a mixed fraction? Why are you being silly, Whiteout? Okay, this is a mixed fraction. What is going on there? If you had to use words to explain what a mixed number is.
What are you looking at me?
Because you started. You gave me this example.
Well, I don't remember what it was. I'm pretty sure the 2 means it's like times or something.
Okay, good guess. Yeah. The 2 is the whole number. So what this is a whole number. And it's not multiplied, Garrett, it's plus, so it's added to. So you have a whole number, and you're adding to it a fraction. So this is 2 5/6 of something. So your example, I would have 2 whole pizzas. How do I cut this thing into 6 nicely? Let's go that way, and that way. So this is 2 whole pizzas, and then 5/6 of a pizza would look like this. Where I've got 6 slices, and then 1, 2, 3, 4, 5 slices. The 2 wholes, and then 5/6. That is a mixed number. Cool? Thank you for the example. It was correct. So when we're working with fractions, we always want to make sure that our fractions are simplified. We want them as simple as possible. Simplified, reduced, lowest terms. This is all the language we use around this stuff. And we've kind of already done it on the previous page. If I had 6 slices to start, my whole pizza there was, I had 6 slices, I've still got all 6 of my slices, but if I took half of the pizza away, well, we said that when I asked you if we were splitting it between 2 people, you guys said, well, each person would get 3 of the 6 slices, but we also talked about how that is just half of the pizza. So what did we do to get from 3/6 to a half? This is where we reduced. But it's important to remember that even though these are reduced, they're still equal. So 3/6, I want to show you how to do it in case we've forgotten. 3/6 reduces to 1/2, but 3/6 is also equal to 1/2. Yeah, Garrett.
Because the 3 is, the 3 is half of the 6, and then 1 is half of the 6, which is equal to both of them because they're the same.
You bet. Love that. So how do we do this consistently? There are 2 methods I'm going to give you for simplifying these fractions. You can pick whichever one you feel most makes you happy inside. Here's the first method. The first method for simplifying fractions is to divide the top and the bottom. It says here with prime numbers to get whole numbers, but I'm going to change this. I'm just going to, we're going to change this. We'll scribble this out. They don't have to be prime. I'm just going to say divide the top and bottom with small numbers that go into both. Don't worry about whether or not they're prime. Doesn't matter if they're prime. As long as they're small and can divide nicely into these, you're good. So here's how you find those kinds of numbers. 6 and 54 have something in common. What do 6 and 54 have in common? Was that Liam? 2. How do you know? They're both even. So because they're both even, that means they're both divisible by 2. The 6 is easy. 6 divided by 2. It's a small multiplication. What is it? Someone said 3. 6 divided by 2 is 3. The 54 is going to be a little bit more difficult. The 54 divided by 2, that's beyond what your multiplication table does. So let's take a look at how let's review long division. Yeah? Do you know it, Dakota? No. Let's review some long division. If I want to take 54 and I want to divide it by 2, how many times does 2 go into 5? Goes in twice. So we put the 2 up top. 2 times 2 is? And now we subtract. 5 minus 4 is 1. You can bring down the 4. So does 2 go into 14? How many times so? Goes in 7 times. 7 times 2 is 14. When I do this subtraction, I get 0. So then 54 divided by 2 is 27. So simplifying fractions is going to take some reviewing, either long division or your use of the multiplication tables. Maybe we should give us a bigger multiplication table. So we're going to get 3 over 27. Is that thing as reduced as it can go? No. Garrett says no. Why not, Garrett? You're right. Why?
Because 37 and 3 can be divisible.
They can both be reduced by?
2 or 1.
Well, 3 is not even.
No.
So it can't be divided by 2.
By half.
Well, we can't divide it by 2 if it's not even. Sahil, 3 is divisible by 3. And if you take a look at your, it's nice to check. If something's divisible by 3, gentlemen, it's going to show up in this column. So 3, my 3's column, 3 is divisible by 3. And if we take a look all the way down here, 27 is also in that column too. So 3 and 27 are both divisible by 3. I'm going to divide this thing by 3. I'm going to divide this thing by 3 as well. 3 divided by 3 is 1. And 27 divided by 3 is 9. And now, I can't divide 1 by anything. So we're done. There's another way to do this that I'll show you here to make sure that you've at least seen it. What we can do is we can find what's called the biggest common factor of these two numbers. Or another way to think about it is, what is the largest number that goes into 6 and 54? When you're simplifying fractions, the first thing you can always check is, does the top number go into the bottom number? If you've got your multiplication tables memorized, you know the answer to that. If you don't, let's take a look at the multiplication tables. Does 6 go into 54? Well, on the 6 tables, do I hit 54? Yeah, there it is. 6 goes into 54 9 times. So I can divide this by 6. I can divide this by 6. 6 divided by 6 is, and 54 divided by 6 is, and we can go straight to that point. 6 divided by 6 is 1. 54 divided by 6 is 9. We get the same answer, which is good. We should get the same answer because we started with the same question. And it doesn't matter which method you choose to use. We've got a technique for it. Duden, was that a hand up? Was that a question? Okay, it wasn't. So here's what I want you to do. I want you guys, if you haven't yet, I want you to take a look at this page. I want you to write out for these three questions. I want you to read what's there, and I want you to make me the fraction, and then I want you to reduce those fractions. That's the rest of what we're going to do today. I'll come around and help where needed. If it hasn't been, some of you have done it already, that's great. Let me check it at least. I want you to give it a shot. Okay, find me this page, sir. There, that's good. Yeah, name on the board. How are we doing, gentlemen? Hey, done yet? Need some help? We're going to give it a shot. Okay, let's talk about it. This says that someone named Caroline baked 12 cookies. Eat 4. So you would have 8 left over, but that's not what the question is asking. The question is actually asking what fraction of the cookies did you eat? So that's how many were left. How many did you eat? He ate 4 of the 12. So 4 on 12. And then you reduce. So start with 4 on 12. Yeah. And then you reduce this. Can you divide 12 and 4 by the same number? They're both divisible by 2. Okay, so divide both by 2. Yeah, divide by 2. Yeah. Yeah, over. No, what's 12 divided by 2? What is it? No, that's times. Where's your number line? Or this, excuse this is using this is not here. Okay, 1 divided by 2. So we're going to go down here. 12. So you go in the 2's column. Over 12. Over here. 12 divided by 2 is 6. Now the question is, can we go further? 4. 2 on 6. Can you go further? 6 is even. And so is 2. So you can go further. So we're going to divide again. Multiply 2 because this is even. And this is even. So 2 divided by 2 is? Divide that times. 2 times 1. Nope. You want to go down to 6. 2 times 6 is? So 4 over 12 reduces to 1 over 3. Yeah. That's right. Try the next one. Zach, is this on your side? Are you the one with the strong block here? Yes, Bill. Why is it 24 18? She has, read the whole question. It says she has 18 number 2 pencils and 6 number 3 pencils. So what fractions of the pencil are number 3 pencils? How many number 3 pencils are there? How many pencils are there total? So then the fraction is going to be no. Oh. And then 36. Okay, so then before that. No, you don't have to subtract. You just want the fraction. So if there's 6 pencils that are number 3,
3 times
and
4
there's
equals
24 pencils total. The fraction is 6 on 24.
3 times 4 equals 3 times 4
And then reduce. Wow, this process is good. Four. How many were there to start? So this first fraction should have been 4 over 12. It says how many cookies did he eat? What fraction of cookies did he eat? He ate 4. So it should be 4 over 12. Process you did, you simplified it properly. You just didn't put it in a fraction. Okay, let's talk, Jordan. What are you working on? Which one you go there? Nice. But hold on. It's 5 divisible by 4. Stop. It's 5 divisible by 4. But now a different number. Stop. What's the first number that goes to the 5? Yep, no. Hold on, no. Maybe. So you're cool with 5, you divide 5 by 5? Yeah, you divide 20 by 5? Yes. So then 5 is the number you want to divide. What do you divide? Divide by 5? Yep, 5. 5 divided by 5 is 5 divided by 5. Anything divided by itself is 1. Yes. And then 20 divided by 5 is 4. So divide both by the same number. You divide 6 by 2 as well.
1.1.
6 divided by 2 is? Perfect. This one's good. No, that one's good, because you divided them both by 2. You divided them both by 3. But can you go on? Can you go further? Look at 3 and 9. Can you divide 3 and 9 by anything? Yeah. Is 9 also divisible by 3? Well, can we do another 3? You can't divide 3 by anything bigger than 3, so you should check 3. Yeah. You divide that one by 3, and you divide it on the bottom by the same thing. Ethan, turn around, please. There you go. Okay, next one. You want to divide them both by 4. 15 divided by 4. 32 divided by 4. So if you want to divide it by 4, you start with the column, divide by, yeah, that's it. Now the question is, have you gone as far as you can go? No. Look at those two numbers. You have a 2 and you have a 2. Yeah.
We took one.
You have them. I know, we took them.
We need to.
Actually, George, here's what I want you to do the rest of these things. For. And you need to pack up. Okay, grade 9s, I want to show you one thing before we leave. As you guys are here, or as we get into the fall, you might be getting sick. You might find yourself absent. I want to show you guys what I've done for all of us. Whether you realize it or not, there is something that you have access to called Microsoft Teams. How many of you used Microsoft Teams before in a class? Fantastic. So this is your guys' Microsoft Teams here. I have activated it, and I have posted one thing in there so far. In the main channels, I have one post that says the YouTube playlist of lesson videos. If you click on that, it will bring you to this year, semester 1, block B, which is you guys, math 9. And all of the videos that I record are going to be, all the lessons we do, all the videos are going to be here. So Monday's video, there was no video on Tuesday because you guys had the assembly. There was Wednesday's video, yesterday's video, and after school today, today's video is going to go up. So this is there in Microsoft Teams. You can use this whenever you're away, or if you're in another class. I'm going to add you to my team, so you have access to this thing. So if I could make sure I do that before you and Jordan leave. I want you guys to try and get this page done. And tomorrow we're going to go look at mixed and improper fractions. So, yeah, that's it. That's your homework. Monday. The next day we meet. When the bell goes, you may also go have a good weekend.